Hi all, and welcome to this video. This is basically a complete tutorial on how to set up Ubuntu 18.04 desktop experience with Tensorflow GPU, Cuda, CUDNN, and anaconda-navigator. So let's get started. Jump into your Google Cloud platform. If it's your first time signing up with your Google account, there's $300 for free, which you can basically use to play around with some deep learning algorithms in the cloud, for example, if that's what you want. So the first thing you do is you click on Create Instance. You have your name. It's up here. For me, it's instance 6. You can choose your you can choose your region, whichever you're comfortable with, or whichever you like. Nothing specific, but whatever you choose, make sure that it has GPUs, since not all of them has GPUs. So for me, we're going to use NVIDIA Tesla V100, sorry, which I believe is one of the most powerful ones out there. I'm just going to have a little bit of memory here. So we got that. Then you're going to change your image to Ubuntu 18.04 LTS and make sure you have 15 gigabyte of hard disk. At least if you keep it as 10, this wouldn't work. So because you'll need a lot of space, and then you want to allow the traffic. So that's that. You click create and you just give it a few seconds, and Google is going to give you a nice instance with a powerful GPU in seconds. So when the instance is ready, you SSH into it. So I'm just going to make this big here. Text size is the largest. Okay. Once you're in, you do sudo apt-get update. And then sudo apt-get upgrade. Y, which means yes. Okay, clear the screen and now type this in order. Sudo apt-get install genome shell space Ubuntu genome desktop space auto qtsil space genome core space genome panel space genome themes standard -y. Make sure there's no any typos. Okay, and this will take some time, and I have a typo. Unable to locate. Yeah, it's auto cut, sorry, not auto cute. Yeah, so this will take some 15-20 minutes. While this is running, just minimize this, and you have to download and install two things. The first thing is you need to download the GCP console. So you go in here. Not this one. Oh, this one, sorry. The Cloud SDK, which is basically a command line that makes you access your virtual system. So you scroll down until, yep, there we go, view tutorial. And then we're not going to go specifically into this, but just make sure you choose the right platform and get the right package. So for me, I'm using Windows 64, so I went for this. I don't need Python, so I already got Python via Anaconda. So you do this and just make sure you follow these instructions. And when you're finished, you're going to have a Google Cloud SDK shell right here, which is a terminal straight into your compute engine instance. So with this SDK shell, I can access all my SDK engines, and you need this. So that's the first thing you're going to download. The second thing you're going to download is the VNC Viewer. So do that, download VNC Viewer. Yeah, realvnc.com, and make sure you have the right platform selected or operating system. Again, when you click on here, you will get this. So this is how the end product looks like. So you need both of these things in order for us to continue. The Cloud SDK shell and the VNC Viewer. So do that while it's running the SSH here. It will take 15-20 minutes, as I said. So yeah, see you when you're finished with all of this. So once you have the GCP SDK downloaded and up and running, the VNC Viewer up and running, and this is finished, we can now move on to the next step. So type touch tilde tilde /x resources. Okay, so if we type lsla, there it is. So it's been successfully created. So let's make sure nothing is new here. So just type sudo apt-get update for a quick update. Yep, there was something. Next, type sudo y. Well, it's the same thing as earlier, just different location. VNC for server space xfce4 space xfce4-goodies. Let it run. So what this is basically doing is installing the VNC server, which we will use to communicate with your VNC viewer via GCP PuTTY. So don't worry about that. If that doesn't mean anything now, we're going to go through everything together. Once that's finished, type VNC server, give it a geometry of 1024 by 640, and give it a depth of 24. Enter. You will require a password, so just write your password, whatever your password is, and you're going to get this message at first. That's okay, and that's that. Now type VNC server -kill1. Okay, and next type sudo nano. I'll explain in a second what we're doing. Tilde /vnc/x startup. There we go. We had to run the VNC server geometry first time for it to auto-generate this file. If you would have went sudo nano into this file and you haven't did the VNC server, this file wouldn't exist. So then type exec user bin. So go to the last line, yeah, and type this start xfce4 and okay. So exec space /user without the e /bin /start xfce4 and control X Y enter. Okay. And now we start our VNC server again. So VNC server geometry, enter. Now you go into your GCP, your cloud console, and you type this. So you're going to type gcloud, compute, ssh, and then your instance name. So my instance name is 6, and I can tell that because it's right here. That's my instance name, instance 6. Space and then your project name. So my project name is Rosie Decker 261119 space zone US West 1B space --/flag -L space 5901 localhost 5901. So you should type this exactly. The only difference is that you should have a different instance name and you should have a different project name and a different zone. The rest should be the same. And then you click enter. And then PuTTY should come. And yep, so it comes up. So this is the first thing it's gonna tell you, and you just click yes. And this comes up here. So you click on your VNC viewer and you have this, and then you just type localhost 2:5901 and click enter, and then voila, this comes up here. So click use default config and just click send, so the reporters have something to do, the developers have something to do, and there you go, you have your VNC viewer right there. Minimize all the noise and just have both of these right next to each other. So then we have a super clear thing. So there you go, you have your cloud desktop GUI, the graphical user interface, and you have the terminal here to your left hand side. Just ignore these for now, they won't help. Okay, so now the first thing to do is we need to get Cuda in place, and if you look in here, it's tensorflow.org/install/source, and you have three options. You have the Linux, the Windows, and the Raspberry Pi. We're going to build our source on the Linux, so we're going to click on Linux. We scroll down a bit and there should be a table. So if you want to have TensorFlow CPU, if you want to have TensorFlow GPU, and then you have the Mac stuff. For me, I will use TensorFlow GPU 1.14. That's because it works very well and it supports all I need for now. If you want TensorFlow 2.0 for those, then you just follow the one above here. But TensorFlow 2.0 is this, even it uses the same CUDNN and Cuda. Okay, so let's get to the point here. Cuda, TensorFlow GPU 1.14. We're gonna first download and install Cuda, and then we're gonna download and install CUDNN, and then we're gonna update the graphics card, and then we're gonna get TensorFlow GPU 1.14. And we have to do it in this order, or things will break. So let's start with Cuda 10.0. So you go in here, click on the browser on your VNC Viewer system. It's a bit laggy, and that's because this system takes screenshots. So type in developer.nvidia.com Cuda toolkit archive. And we said we wanted 10.0. So scroll down and you go to Cuda 10.0, this one right here. Click that, scroll down, and then go for Linux, since this is a Linux system, x86 64-bit architecture, Ubuntu 18.04 LTS, that's what we're using, and choose the logo. And click download. And you save the file, and you click OK. And while it's downloading, you go into your downloads. This is going to be much faster than your local internet because this is using the cloud internet. It's not using your local internet. So change directory to downloads and wait for it to finish downloading. And now it's finished, ls, and there it is. So then we're going to type sudo dpkg space -i and then Cuda and then tab, and we click enter. So this will take a few seconds. So this second step, just ignore it for, don't do the second step because it's gonna tell you, usually at least it does tell you. So we're gonna give it some seconds here, and there we go, there's the second step already. So you just copy this and you get this nice scissor symbol and you do paste, and then you get OK, which is perfect. And now you do sudo apt get update. Now you follow the rest of the instructions, and then after that we're gonna do sudo apt get install Cuda, and this is around 3 GB, so this is gonna take perhaps 10 minutes. So I'm gonna pause the video and come back when it's finished, but you can at least click on download patch, so it's ready. So after we finish the base installer, we're gonna do the patch. This is gonna take a while, so just be back when it's done. So now that's finished and we have downloaded the patch. So let's download the patch, and funny enough, it doesn't give you instructions, so it's like, oh, you go figure it out yourself. Well, thanks NVIDIA. So you type sudo dpkg space I, and then make sure you're not choosing the wrong one, so it's NV, oops, sorry, NV. So make sure you get this one and not the 10.0, and if you click here, just look at the latest one, so NVG, and you click enter, and then you type sudo apt get update, and then when that's finished, you can see it's getting the Cuda repo files here, and then you do upgrade, and that's how you actually install the patch. There we go. Click yes. So now, after this is finished, we got Cuda 10.0 with the patch up and ready. So let's do a quick sudo reboot, which is gonna restart the system. Of course, when you do that, it's gonna destroy this. So if we do this, you're gonna get all sort of errors. So just close your PuTTY instance, but keep this on. Just wait for 10 seconds, literally. 10, 9, 8. Then you click reconnect, and it's gonna reconnect, and just hit the up arrow and click enter. So this is gonna fire up the PuTTY, and then with the PuTTY you get into your VNC Viewer, and then you're back again. So the next step now is to add the Cuda into your bash.rc. I'm gonna show you how to do that. And then we will uninstall your NVIDIA card and update it. So I'm going to also show you how to do that. But let's wait for it to reconnect. Okay, so we are in. I had to click retry a few times, so it actually took more than a few seconds. So again, go to your Google Cloud SDK shell and click enter. It will fire up PuTTY. And then just minimize the noise and get on with your job. Localhost. Actually, when you click this, you're going to get an error. The connection closed unexpectedly. And that's because you have to restart your VNC server. So just do VNC server geometry 1024, which is the geometry of the sphere, and depth 24. I found out that works best for me. So, and then it's going to tell you if it's up and running. And then you come back here, and now you can get on with your job. There we are. Some gray screen, just give it a few seconds and it will if it's like this, just close it and just open it one more time, and then it fixes itself. Wow, so reliable and stable. Okay, let's get to the point. So a few things we want to do here. I'm gonna put these down in the description. So you want to do echo export path user local CUDA bin to your bash RC. So that's the first thing you want to do, and then you want to do the library path. Okay, and then you want to do source tilde source tilde /.bash/rc. There we go. So if we jump into our bash RC, we will find these two here added at the end. So if we just go down, and the reason there they are. So we got these two here, and the reason we did it that way, so you don't have to export the variable every time you restart the PC. Okay, we're gonna do two things. Let's first do NVIDIA SMI, and it says the NVIDIA SMI has failed because it couldn't communicate with the NVIDIA driver. Make sure you have the latest NVIDIA drive installed and running. So this is what we're gonna do. But before we do that, let's do NVCCV and also something bad like fatal. Do we have the version unknown? Can we do a double comma? There we go. So there we are. So we got the Cuda compilation tool released to 10.0, and that's the version. So that means Cuda is working, but your NVIDIA is not working. So it says failed. So let's fix this. So we're gonna uninstall the NVIDIA card that you currently have. So that will be sudo space, whoops. Okay, I'm gonna paste it really fast. But I'll show it to you again once this is finished. So we're uninstalling your NVIDIA current version, and we're gonna update it. We can see here it was 4.10. So yeah, NVIDIA blah 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 blah, whatever, we don't care. We're gonna set it up properly. So now it's finished, but the NVCC version is still there. So your CUDA 10.0 is still there. So what I did was basically this here, sudo space apt-get purge NVIDIA-star, which purges anything that has an NVIDIA dash onwards. So now we've done that, so let's just clear. And let's type sudo apt-get repository ppa colon graphics dash drivers / ppa. Command not found, so I probably misspelled something. What did I misspell? Probably this one, because I can't spell it ever. Repository. Oh yeah. Not sure what's the problem. Let's see. Yeah, so it was a repository misspelling. So then you get to this, just click enter to continue, and it's gonna update your repository. So you're gonna get what versions that are suitable. So this was the code. So it was not sudo apt-get repository, it was sudo add apt. So that was the mistake that I've done. And then you just do sudo apt update. And then you upgrade. There are 12 packages now that are upgradable. And then you upgrade your packages. Upgrade. No, don't upgrade. Upgrade, please. So let it upgrade. After it's finished upgrading, then we're gonna type in Ubuntu dash drivers dash list. Command not found, because you shouldn't put a dash after drivers. You want to list them, and then you're gonna get a list of drivers that you can update your V100 with. There we go. Fantastic. So we're gonna now type sudo apt install NVIDIA driver dash. You want the latest version, so it's 440, and we click enter. Yes. So now we're updating our NVIDIA card. So, and then we're going to restart our system, and then we're going to type that command one more time, and it should find our V100 graphics card, and that should be compatible with our Cuda installation. So after we finish both of these, then we're going to install CUDNN. Once you're done with this, do a quick reboot. So same drill again, just don't wait for a few seconds this time. Give it a minute, reconnect, close your putty, keep this open. So you give it a minute, you reconnect, you hit the up arrow, you connect, putty launches, and you jump into your VNC Viewer. So do the drill. So I'm now reconnected. I'm just gonna click enter here. Launches putty, finished, localhost. Guess what happens? Connection refused, of course. VNC server geometry 1024 640. You can actually do this automatic. You can make sure that on reboot the VNC server with this geometry and depth starts. You can do that if you want, but I like to manually do it just to make sure, for security purposes basically, so that no one can access it if I'm not having it. So it's up to you. It's just a preference that I would like to control it. I don't want it to fire this thing automatically. Okay, so now let's type in NVIDIA SMI, and it should give us something. There we are. It worked from the first time. Magic. So there we go, NVIDIA SMI 440. So that's the driver version we have. There we go. There's our Tesla V100, and we got 16 GB of graphics card, and it's currently free, ready for us to use. And then if we go NVCC version, and our Cuda is also still happy. Fantastic. So we got our Cuda, we got our NVIDIA. Next, let's do CUDNN. So hop here, and we need to go to the CUDNN website. With the CUDNN website, you will actually need to have an account on there. Oh, really smart. It remembers where we were. Firefox, thank you. So developer.nvidia.com rdp/CUDNN or CUDNN archive. Enter. There we go. So we have this. Right, there's several versions. Remember from our TensorFlow support, let me open that again. TensorFlow, let me find it. Give me a second. TensorFlow GPU support. Just typing links off the top of my head. Give me a second. Yeah, it was install support. Or install GPU, maybe. Wow. Okay, scroll down. Nothing. Yeah, click on Linux, Mac OS. Scroll down till you get the table, and there we are. So we are aiming not the CPU version, but the GPU version, and we're aiming at this here. So we got Cuda and the drivers ready. Now we need Cuda 7.4. So the CUDNN should match the Cuda. So your Cuda is 10.0, but you want to get Cuda 10.0 for CUDNN 7.4, as if that wasn't complicated enough. So they make it even more complicated. Okay, so Cuda 10.0, and you want the latest version, which is 7.4.2. That was released in December 14, and you click on that. And then you scroll down a tiny bit, and then you need to install the runtime library. So 18.04 runtime library, that's your first click, and you have to log in. So log in. If you don't have an account, click join, otherwise do log in. I'm just gonna log in with my Facebook. So be right back, which is right down here. When you click here, click on login with Facebook. So once you're logged in, apparently it doesn't redirect you. So just go back. It says continue to download, but you want to download several other things. So it'd be nice, NVIDIA, if you can just redirect us after forcing us to log in. If we scroll down a little bit, we got, let's go back. So 7.4.2 for Cuda 10.0. And we scroll down. So the first thing you want to do is you want to get runtime library. The order is important. I can't stress the order of this. So we click OK. Now click LS. We go to downloads. Oops. Downloads. And there we are. So just type rm-rf to remove all the Cuda stuff, so you don't just confuse yourself when it's piling up. So local, what is it, 10, and then you have another space, so just also do the other one, Cuda. Well, it should be smart. I mean, you can't uninstall something twice. So, but anyways, it's not that smart yet. So rmrf, click enter, and ls, and there you go. You only have this one left here, which is the runtime library. So we start with doing sudo dpkg I, and then installing the CUDNN. So that's the first thing. So you wait for it to be finished, because if you get the order wrong, you have to repeat everything. Literally. Wait for it. Once it's finished, what I would do, just to be on the safe side, I'm gonna also remove it, so I don't mix it up with other stuff. Next, you want to have the developer library. Click save. It's already finished. So again, sudo dpkg I have that there. Enter. It's unpacking. And then we're gonna remove it and then install the code sample and user guides. You use this to actually run a test to confirm your installation. That's an extra step if you want to do it, but I just install it just in case, but I don't run the test. But you can run the test if you want. So I'm just going to remove this, again, to not confuse myself with all the Cuda coded names. Save file. Okay, finished. I'm going to assume it's there. And enter. Finished. So rm, rf, and it should be lib, and we delete that, and our downloads file is clean. So now we actually got CUDNN in there. So the next step is to download Anaconda. Finally, we can get to the exciting point of this. So download, geez, what am I doing? Download Anaconda. Go there, download, and choose this one here, the 64-bit 86 installer. You click save file, you click OK. There it is, few seconds, and it should appear here. At least we should get a dot part. It's finished. So we type SHA256 sum anaconda, and we should get back a code. Yep. Enter. Yep, so there it is. Next, we have to download and install. You can confirm this code against the website to make sure you have the right thing, but looks okay. I've done this several times, and I remember it ends up with 53, but with the future versions it'll be different, so you can check. And then you just do bash the script, enter, just hold on enter. I've read this before, so if you want to read it, please answer yes or no. Yes, enter. If you want to be in the default directory, I want it to be in the default directory, so yeah, so it will download and install. It will install now. Sorry, I'll be back when it's finished. Next, you're gonna get this. Do you wish to install or to initialize Anaconda by running conda init? Click yes. This is so critical because the default is no. There we have. So now we have Anaconda 3 up and running. Now we need to create a desktop icon for it, so it's easy for you to launch. So because if you go in here, it's just Anaconda 3, and you're like, oh my god, where do I click? What do I have to do? So for convenience, we're gonna create a desktop entry point. So just write as follows. Sudo nano home, your username, which is my name in this case. Actually, no. Sudo mkdir home bin, enter. Now we have a bin here. Next, you do the sudo nano. So just do sudo nano bin / anaconda.sh. So it's a new file. I'm just gonna paste this here. Oh, what happened? Okay, let's try this again. Paste. Okay, I see. So it just did it all in one line. Okay, just let me fix this. That looks like it makes more sense. I'm gonna go through this. Just give me a sec. Just get rid of these spaces. Okay, so export conda_python_exe equal home username anaconda3 bin python, and then it will export the path anaconda3 here, and then you have the navigator. So just make sure to follow this. The only difference is you put your username instead of my username, because it wouldn't make sense if you added my username. Control X, save. Next, you want to do sudo nano home username desktop. Is it the capital D? Yep, desktop anaconda-navigator. Bam, excellent. Then I'm just gonna paste this. Pasted nothing. Let me try one more time. There we go. Okay, so let me just fix all the things all over the place here. Can we go to the end? Thanks. So startup has to be down here. Desktop entry, the version looks like a mess. So then the type goes down, and the name, then generic name. This is the XPath icon. We need the terminal to be in a new line. Yeah. If you want the terminal to be on, so just make it okay. So this is what you need. I'll make sure it's written down there also. So desktop entry, type application, generic name. Control X, Y. Okay. Why are we still here? Let's go to the desktop. And there is the anaconda-navigator. And then we type sudo desktop file install the anaconda desktop. Oh, that was wrong. Anaconda.desktop. Okay, what did I do wrong? I think I created the file name wrong. Sudo, what did I do? Anaconda-navigator. This is wrong. Okay, sorry, my bad. How do we, was it sudo move anaconda to, I think this is how you rename, don't remember. Okay, that's how you rename. Yeah, so please rename that. Sudo move anaconda-navigator to anaconda desktop, and then now try this again. Still get an error. Okay, let's read this. Desktop is not a known version, error value 1.0. Okay, why? Let's go back. First error of the video. I'm actually quite proud. Well, now we know this doesn't exist anymore. So it has to be some space issue somewhere. Yeah, maybe it's all these spaces. Try now. No. Failed to validate. So, okay, so at least it's a different error now. Terminal contains invalid characters. Okay, but it's false. Probably there's a space. Yeah, just make sure you don't have these spaces. Do we have space up here? Yeah. Okay, just really be careful. It's super sensitive. And oh, there are spaces everywhere. Okay, now we should try again. Yep, there, no error. So hopefully it worked and didn't give up on us. Next thing you want to type is sudo change mode +x space star.desktop. Star.desktop. Okay, the moment of truth. Go away. I'm so excited now. Double click here. And we should get Anaconda, ladies and gentlemen. There we are. Great. We have Anaconda. And we have an environment, and we just click create, and let's call this test Tensorflow Python 3.7 create. It's creating our environment. And then you go to all, and then you type tensor, 10, okay, that doesn't look correct. Click update index. It's missing so many libraries. Actually, let's do a conda update conda. Yeah, so let this run. I'm just gonna close it for a second here. And let's just do conda update conda. Conda not found. Yes. That means it's not registered in your bash RC. Okay, let's do a reboot. But okay, let's do the reboot later, because I think I know the fix. But let's first do this, and then we have to actually, what if we do this? Source bash rc, maybe. Aha, there it did. Good, good. So actually we just had to bash the RC, and I'm gonna tell you how to fix this. So we have several issues here, but after you install conda, just do source tilde/bash rc, and now do conda update conda. Now it should work. Yeah, but just close this. Okay, so it's updating your conda. A few updates here and there. Well, we just installed it from the website and it's not even updated. And then conda update anaconda-navigator. Yep. Excellent. There we go. All packages already installed. Well, I would expect that if I installed it straight from the website. Now let's launch Anaconda Navigator again. Hop into your environments, test TensorFlow. Click here and then type just click all. Then type TensorFlow dash GPU. There we are. So TensorFlow GPU. Now be very careful. So click on TensorFlow GPU and then right click and then mark for specific version installation and then 1.14. Remember, that's our Cuda, CUDNN, and all the versions on Earth. Okay, click apply and this comes up here. Apply. Installing the packages, you say fetching CUDNN and making sure that all our versions are correct. Sorry, go back to environments. Still installing packages. We wait for that. And now it's finished. So go back to your home, scroll down slowly. There we have our Jupyter notebook. We'll install it to our test TensorFlow. And then if we just say TensorFlow test GPU, I think there is a code somewhere online. Yeah, test if the GPU is available. How to tell if TensorFlow Okay, you launch this. Okay, TF test is available. Limit the search to CUDA GPUs. Okay, so CUDA only false. So this is gonna check if we have a TensorFlow, if the GPU is available. Number GPUs available too. Cool. Okay, let's try both of them. So let's jump into our desktop. Open a Python 3 script. Let's copy this code. We can't. Yeah, whatever. So import TensorFlow STF. Warnings, as long as it's no errors, you're fine. Let's make sure there was no errors. Yeah, just warnings, fine. Moment of truth. True, yes, everything is working. Wow. Now you have a desktop running on the cloud with the most powerful graphics card for free. Thank you, Google, for your $300. Number of GPUs available is 1. Well, not 2. You can just for fun start checking here and start printing, and yeah, your tensors are working very good. I'm just procrastinating now on different things, but one physical GPU, one logical GPU. This is really fascinating, and it's really a good time to be alive to have a GPU for free available somewhere. Okay, now there are a few things we have to, just to make sure everything is working right. When you do sudo reboot, and I will show you, there's one more thing, and I have witnessed that, is that when you reboot, it's gonna start in the base. And I'm just going to show you a code so you don't have to always start in the base. close putty. So when you reboot or when you shut down and you want to go back into your system, usually it will start in the base environment, and we don't want to do that. If you want to do just normal things, you don't want to be installing only on your base. You want to install in your base when you want to install in your base. But let's see if it happens now. Yes, so it says base here. So what you want to do is you want to type conda config -- set auto activate base false. And now if we do another reboot, it shouldn't come on automatically. Let's see. Yeah, I get this sometimes. Just click retry. Okay, so let's see if we get it this time. Previously we had this base. There we go. You don't have that base anymore. One last thing, if you don't want to use version 3.7, I'm gonna show you also a quick thing. Just hop in, make sure you do start your VNC server geometry. Again, as I said, you can just automatically do this. So many of the packages out there don't work properly with Python 3.7. So again, when it's shitty like this, just kill it, open a new one. There we go. So another thing you can do is type, for example, if you want the Python 2.7 and 3.5 and 6 is already here. So you just do conda create name, and I'm gonna call this test 36. Okay, I froze. Then type Python equal 3.6, and you click enter and wait for it. Then you click yes. So we're trying to install a new, double click here to go back to your Anaconda. Why does it have this up? Okay, whatever. We need smarter systems. Never mind. So let it initialize. Get all this funny mess here. There we go. And if you go to environments, you're gonna see it's here. Look, test underscore 36, which wasn't there before. And then you do the same thing. You install Jupyter, and then you have it up and ready. You have several versions here. So if you do Python, I think you have 2.7, and if you do Python 3, you have 3.6. And if you do Python 3.37, I think. Oh, I don't remember what I did. Yeah, but you have several Pythons, and I wouldn't want to mess and install any more Pythons here. I'm gonna install any version in the environment. That's the end of the video. If you have any questions or comments, please leave it below. Otherwise, feel free to subscribe to my channel, and I'll be posting similar videos again soon. Goodbye.